All right, welcome. Today, we're going to take a grand tour of our home planet. We're going to peel back the layers, literally, from its fiery core all the way to the air we breathe, to really get a handle on what makes this world so, so special. So let's dive in. And we have to start with this. This is the single most important, most profound fact about our planet. I mean, think about it. Of all the trillions of stars and countless galaxies out there, this little blue marble is the only place we know for sure has life. That one fact alone makes Earth a total anomaly in the known universe. And its story, well, it's a long one. It unfolds on a timescale that is just almost impossible to wrap your head around. 4.5 billion years. That is the huge, vast canvas on which our planet's entire history has been painted. So for the first leg of our tour, let's look at the planet's most defining feature, the thing that gives it that famous nickname, the blue marble. Earth is, first and foremost, an ocean world. Just let that number sink in for a second. Over 70% of our world, it isn't land at all. It's one giant, single, interconnected global ocean. Which, leaves just under 30% for everything else. All the continents, all the islands, all bundled together. This wild water-to-land ratio is basically the starting point for understanding almost everything about our planet, from our weather to how life even evolved. Okay, now here's an idea that might just blow your mind a little. We think of Mount Everest as being this colossal peak, right? And the Mariana Trench as this impossibly deep chasm. But this quote, it tells a totally different story. On a planetary scale, Earth is incredibly smooth. If you could actually shrink it down to the size of a billiard ball and hold it, it would feel even smoother to the touch. Isn't that wild? So, if the surface is that smooth, what's happening underneath it all? For our next stop, let's dive deep into the planet's interior, the engine room that's driving all the drama we see on the surface. You can kind of think of Earth like a giant onion with all these different layers all the way down to the middle. And way down there, deep inside, the churning of that liquid metal outer core does something absolutely amazing. It generates a massive magnetic field, like an invisible force field, that protects the whole planet from dangerous solar radiation. But that internal heat does a lot more than just create a shield. All that heat has to go somewhere, and it powers this incredible process, plate tectonics. See, the solid ground we live on isn't one big piece. It's actually broken up into these massive plates that are always, very slowly, moving around. And where they crash, pull apart, or grind past each other, well, that's where we get all of Earth's geologic action, volcanoes, earthquakes, and the creation of giant mountain ranges. Okay, so from the solid rock under our feet, let's move outward to the two systems that make everything else we've talked about possible. I'm talking about the planet's life support systems, its water and its air. So, take a deep breath. What are you actually breathing in? You might think it's mostly oxygen, but surprise, it's actually mostly nitrogen. Over 78% of our atmosphere is nitrogen. That all-important oxygen we need to live, that's only about 21%. And this gets to the atmosphere's most important job. It acts like a giant invisible blanket for the planet. Certain gases trap just the right amount of heat from the sun. Without this natural greenhouse effect, the average temperature would drop to a totally frozen -18 degrees Celsius. Our ocean world would be just a big ball of ice. Liquid water and a nice, stable climate, well, they set the perfect stage for Earth's most unique feature. This is where our tour arrives at the thing that makes our planet a true miracle: life itself. This timeline really puts everything into perspective. Life gets going with simple molecules about 4 billion years ago. But look at those massive gaps in time. It took over 1 billion years just for photosynthesis to get started, and 3.5 billion years before we see that big explosion of complex animals. And us, humanity? We only showed up about 300,000 years ago. We are a tiny, tiny blip at the very end of this epic story. Now here's the kicker. Life isn't just a passive passenger on Earth. Not even close. It's an active geological force. Get this. 2 billion years ago, tiny little microbes figured out photosynthesis, and in doing so, they completely changed our atmosphere, pumping it full of the oxygen that eventually allowed complex creatures, like us, to evolve. Life literally terraformed its own home. And this brings us to the final stop on our tour. We've seen how ancient life became this planet-altering force. And now we have to look at the newest one to show up on the scene, us. If this chart doesn't put our existence into perspective, I don't know what will. On the left, you have 4.5 billion years of Earth's history. And on the right, that tiny, almost invisible little line, that's all of human civilization. In the grand scheme of things, we just got here. And yet, in that geological blink of an eye, we've become this incredibly dominant force. The scientific consensus is pretty clear on this. While Earth's climate has always changed because of natural stuff like solar cycles and volcanoes, the super fast warming we're seeing today is overwhelmingly driven by human activities, especially releasing greenhouse gases from burning fossil fuels. And so that leaves us with this final, really profound question. Just like those ancient microbes changed the planet forever by creating the oxygen we breathe, we are now changing it all over again. The story of Earth is still being written, and for the very first time, one of its own species is holding the pen. So what will our chapter say?